Yes, sir.
Yes. So, uh, so that topic just discusses about the non-living things and the living things, their differences, and what are their effects on other surroundings, other variables. So it talks about how life evolved from unicellular to multicellular beings, which were capable of many other things, and they talked about non-living things, how they helped us, how they helped us, they help life to form, and yes, that's I think that concludes the whole chapter. Yes, sir. We were doing the exploring forces. We were exploring. There's a chapter in the book named as Exploring Forces. It talks about different forces of nature, uh, like gravity, electrostatic repulsion, and uh, and the buoyant force, and muscular force. So it gives a vague description about all of them, and explains how explains things like why does something on water float or sink, and how does something reach the ground if we throw it up. So that was the chapter. Yes, sir.
Yes, sir. Mm, no, sir.
Yes, sir.
Yes, sir. The question was that what is the like real shape of Earth, and I have given that answer.
No, actually, the homework was, yeah, he has to prove it. Or you guys have to prove it, not simply say that what shape it is. What shape is the earth and how, I mean, how can you prove it? That is what your homework was, if I remember. So whenever you are ready, you have to come up with experiment and show us that earth is round. Take your time. I mean, that's not a thing, but think about it and do some research, YouTube, internet, and then figure it out, and then make a presentation and tell us. Always do a good, something if you are talking about. It's a good idea to talk and make a small presentation, like Aryan does it all the time. See, and that's how you should be doing it.
Oh, do
Yes, sir. I also have a presentation. Can I present?
Oh, good. Yes, go ahead.
Okay.
What is the topic? Yeah.
At the birth of astrophysics.
Mm,
Sir, wait a minute.
sure. So, Earth, you can ask Pankaj sir about Sanskrit if you have any problem. I heard that you had an exam of Sanskrit. How did you do it?
So the exam of Sanskrit were not good.
Okay, so ask Pankaj sir. He's a Sanskrit Pandit too. He can tell you about all the Sanskrit you need to know.
Okay, sir. Good afternoon, sir.
He's trying to say, wait.
Okay, so let me just project. Okay,
Okay. Good.
so should I start?
Okay. Yes.
Okay, so the birth of modern astronomy. So, introduction to astrophysics. So, in this, we will be just talking about uh, the humble beginnings of astrophysics, how it was first made, what was the main question that it answered, and about about some important personalities also. So Isaac Newton. So he discovered optics and optics. So optics and Newton fueled astrophysics by transforming lenses into chemical laboratories. He then detected starlight with prisms. Later, scientists performed flawless glass and uh, spectroscopes. Using dispersion and diffraction, they isolated rainbow spectrums and hidden dark lines, unlocking the temperature, movement, and chemical composition of the entire cosmos from Earth. So optics. So as we know that Newton discovered optics, but there was one more thing that he could have done that would have revolutionized and made him more popular, uh, and that was measuring the temperature of colors. So we will talk about that later in this presentation. So he first spread these lights and the nature of light. So light is the electromagnetic radiation traveling across space as a wave. Visible light ranging from high energy violet to lower energy red is just a slice of the full spectrum. Astrophysics relies on this entire spectrum using both visible and invisible wavelengths to unlock cosmic temperatures, chemistry, and motion. So light, so it's an electromagnetic radiation that is traveling across space, and uh, its color tells us its energy. So it forms a whole spectrum and imperfection of that time. So early astronomers struggled with primitive glass that contained structural bubbles, chemical breaks, and uneven densities. These internal imperfections bent starlight unpredictably, creating blurred planetary details and frustrating color distortions. So to decode chemical signatures from space, astrophysics first requires the creation of perfectly pure, optically flawless glass lenses. So here comes a very big personality of this presentation, Joseph von Fraunhofer. So he revolutionized glassmaking by mastering the precise chemical formulas, by systematically stirring the molten glass to eliminate bubbles and internal streaks. He eliminated flaws. This flawless optical glass allowed prisms to cleanly separate starlight into pure unblurred spectral lines for analysis. So, like the things he did, he knew that transparency was required in science, and the thing he did, he created perfect optical glasses. And but what happened that he died very young. He died at 39, and what happened that the state in the country in which he was preserved all of its secrets, and which later uh, was a very big problem for another big scientist. But his past was uh, is not mentioned a lot because he at the age of 11 he was forced to work at a glass factory, and after that he then got to this place and studied how to make perfect optical glasses for these things, and and he did a spectrography and observed lines. So when starlight went through the telescope, it gave us a spectrograph. So there were some absorption lines in them. So Fraunhofer invented the spectroscope by aligning a glass prism with a very high precision surveying telescope. Instead of viewing a tiny blurry rainbow, this magnified the dispersed light into a wide, sharp spectrum. So this was very crucial. So which allowed the scientists to see the dark macroscopic lines that were hidden inside the starlight. So temperature of color. So this is the thing that Newton could have done. Uh, and so another great scientist, William Herschel, who discovered the planet of, who discovered another planet. Uh, so in the 1800s, what he did an experiment which split sunlight with a prism, and he placed thermometers in each color band. The temperature steadily rose from violet to red. Crucially, he placed a thermometer in the dark zone past the red edge, registered the highest temperature, proving invisible heat rays existed. So it was the historic discovery of the infrared radiation. So infrared, so Herschel discovered infrared by placing a thermometer in the dark zone just past the red light. So, expecting ambient temperatures, he found the highest reading of all of them. So, this proved the existence of his invisible heat rays, demonstrating that human eyes only perceive a very tiny fraction of the universe's full electromagnetic spectrum. So, this is how the infrared light was discovered. So, let's get to another uh, important personality, William Hyde Wollaston. So he accidentally discovered this solar absorption lines in 1802 by passing sunlight through a primitive prism. He noticed a few gaps cutting across the rainbow, and believing they were just normal natural borders separating different colors. He failed to investigate further, leaving it to Joseph Fraunhofer. So he also independently he discovered these things, and but he could not. He I think so. He discovered only 7 lines, while Joseph Fraunhofer did 540 plus. So Fraunhofer lines. So in 1814, he mapped over 570 dark lines cutting across the solar spectrum using his advanced spectrograph. He labeled the most prominent gaps from A to K. While he never understood what caused them, he proved these lines were permanent intrinsic properties of starlight, providing the foundation for chemical astrophysics. So, right now, the A, B, and this labeling system is for stars and their temperatures. We'll get to in this presentation only. But here, at Fraunhofer's time, he used this as the closeness, or like if it is in the red spectrum it is A, and if it's in the violet or the other sections it would be rand, like D, G, or K. So this was just like he gave a particular color for each particular uh, specific color of that spectrum. The labeling system. So Fraunhofer's A to K system assigned letters to the most prominent dark gaps in the solar spectrum. He labeled the deep red line A and moved across the rainbow to the violet K line. Today, astrophysics still use these exact designations to identify critical elements like sodium, hydrogen, and calcium stars. Emission lines. So, as you can see in the picture, there are the three different spectrographs. One is an emission spectrum, one is a continuous spectrum, and one is an absorption spectrum. So, in the emission, like in the emission and the continuous, the only difference is the density, or you can say the amount of like the atoms when they are closer. So Kirchhoff and Bunsen revolutionized astrophysics by burning chemicals in a laboratory flame. They discovered that vaporized elements emit unique bright colored bands of light. Chemical or called they called it chemical fingerprints. By matching these emission lines directly to Fraunhofer's dark solar gaps, they proved that they share a very uh, the exact same chemical elements found on Earth. So the solution. So the mystery was solved when scientists realized starlight passes through cooler gases in a star's atmosphere. These gases absorb the same light wavelengths they emit when heated. So the dark lines were just chemical shadows, proving that the chemical recipes of stars can be deciphered entirely from Earth. So they understood at that time. They did not understood what was happening on the atomic level, but now we do. So on the atomic level, it's what happens is that quantum mechanics explains that spectrography is driven by electron leaps and electron orbits and atoms nucleus on a fixed energy rungs. Passing photons are absorbed by electrons to jump in a rug, leaving dark gaps in starlight. When dropping back down, they release the exact energy has bright emission lines revealing chemical identities. So so what happens is that in low energy orbital electron gets in photon, and then it goes to a higher orbital, and then after some times it goes to the lower energy orbital, and it releases a photon which matches the exact energy difference between the higher and the lower orbital. So the three laws. So these three laws define how different celestial environments form spectrums. A dense hot object emits a smooth, continuous, unbroken rainbow, which is in continuous spectrum, and hot glowing gas cloud yields discrete bright bands emissions, and a cool gas layer sitting in front of a hot source creates dark gaps absorption, revealing stellar chemistry. So, as you can see in the picture, the differences between the continuous spectrum, emission spectrum, and absorption spectrum is shown. Wilhelmina Fleming, so she pioneered stellar classification by cataloging with 10,000 stars for the uh, Harvard College Observatory. She devised an alphabetical system A through Q based on the stars' strength of uh, hydrogen lines, where A stars had the most abundant hydrogen. Her fundamental work paved the way for modern astrophysics. So, meaning of color. So, another important personality, Annie Jump Cannon, realized that star color maps directly to surface temperature, resolving the confusion behind earlier chemical classifications. So, by rearranging the mismatched alphabetical categories into definitive O, B, A, F, G, K, M sequence, she successfully organized the entire universe from the hottest blue stars to the coldest red stars. So now we are going to the most brilliant PhD thesis, Cecilia's Penny, 1925 dissertation. Stellar atmosphere is celebrated as astronomy's most brilliant PhD thesis. So by introducing quantum physics to stellar spectra, she proved stars are composed almost entirely of hydrogen and helium. Her work overturned established scientific beliefs and birthed the modern era of stellar astrophysics. So, Hertzsprung Russell diagram. So, It was like it was published earlier than Penny Cecilia. So while the HR, like this diagram predicted uh, her Cecilia's pennies by a decade, her 1925 thesis provided its ultimate physical validation by applying quantum mechanics to stellar spectra. She proved that the diagram horizontal axis directly mapped precise surface temperatures, transforming an observational sorting chart into a mathematically sound blueprint of stellar physics. So the ever expanding universe. So spectrography ultimately revealed the expanding universe in the 1920s. Edwin Hubble analyzed light from distant galaxies and noticed its spectral lines were consistently wrapped towards the redder wavelengths. This universal cosmic redshift proved that the galaxies are flying apart, transforming astrophysics from a study of individual stars to a science of the entire changing universe. So, summary. So, astrophysics fundamentally transformed how humanity reads the cosmos by combining perfected optics with spectrography. Pioneers turned simple telescopes into chemical laboratories. Their collective breakthroughs prove that the entire universe obeys identical physical laws, revealing a shared uniform chemical blueprint hidden inside the invisible wavelengths of stars. So, are there any questions? Anyone? I tried to hurry it because we do not have a lot of time. So, uh, hello, Malik sir. You're on mute. Good evening, sir.
Good morning, Amarnath Ji, and good evening to
Good
everyone.
morning.
Good evening, sir.
Let the students first ask the question.
Yes,
Saksham, do you have any question for him? Saksham, or
something.
you guys get the first chance to ask the question. Then Malik you will ask and I will ask.
No, sir.
No, have you understood all of it which he has said?
Yes, sir.
कौन कौन सा समझ में नहीं आया है?
सर समझ में तो सब आ गया है.
अच्छा, और अर्थ अर्थ आपको समझ में आया?
Yes, sir.
ओ गुड, वेरी गुड. तो आप ये समझे कि कैसे आर्यन बोल रहे थे कि यूनिवर्स एक्सपैंड कर रहा है, कैसे पता पड़ा? आर्यन अभी बताया कि उनको ये लाइन देख करके पता पड़ा कि यूनिवर्स एक्सपैंड कर रहा है, कैसे पता पड़ा?
Yes, sir. Aryan mentioned the spectroscopy in which Edwin
Hmm.
Hubble founded that the galaxies which are going redder means they are going farther away from us.
Then how did he find that?
Um,
वही समझा रहे थे आर्यन. फिर एक बार समझा दीजिए तो आर्यन, कैसे
Okay.
पता पड़ा कि यूनिवर्स इज एक्सपैंडिंग?
So, Edwin Hubble used spectrographs, or got spectrographs from very distant galaxies, and he noticed that the lines, the spectral lines, the absorption lines, all of there was consistently warped, like more steep towards the redder end. And by calculating the rest position of the elements like hydrogen in that spectrograph, and calculating I don't remember the specific formula that we used to calculate the approximate distance between galaxies. So by using that, we can calculate how far an galaxy is moving away from us by looking at its spectrograph.
No, no. So it was shifted towards the red.
Yes,
People call it red shift. So why that means that universe is expanding? वही पूछ रहे हैं आपसे,
Yes, sir.
समझ सक्षम वही पूछ रहे हैं कि
So,
how what is the argument कि रेड के तरफ शिफ्ट हो गया लाइन, सब जितना भी लाइन था, तो
so,
उससे कैसे, क्यों हम सोचते हैं कि यूनिवर्स इज एक्सपेंडिंग?
sir, it's because of the expansion of the universe. What happens is that the photons get stretched to the redder end. So,
क्यों क्यों व्हाई रेडर एंड?
sir, if I stretch something, it gets stretched, and if I tried that with it, it's expanding, right? So what happens is that the spaces between two particular objects is growing and growing. So if we apply that logic to the photons, what happens is that they get stretched and stretched, and in physics, what means like if it's more stretched, it goes to the redder end because it has lesser energy now.
Yeah. So Saksham, just like when you are standing on the platform of a train, if the train is coming, when it is approaching you, so distance is decreasing. So what happens? The frequency of the sound is increasing, wavelength is decreasing. And when the train is going away, you can one day stand on the platform and just observe this. And if the train is going away, you will find that the wavelength is increasing because the distances are increasing. So wavelength is increasing. So that is what Aryan is telling that that there is a shifting of the all the frequency light ka जो red के तरफ means the wavelength became more and red shift was there. So this and all lines, very interestingly, they observed in all the lines. In fact, by shifting, you can also calculate that how far they are moving away from each other. It's very interesting actually. Very interesting observation. But all it happened because quantum mechanics rules the universe. Yeah. Earth, you have any question? Hello, Earth.
Yes, sir.
Yeah, you have understood everything?
Yes, I have a question.
Yeah, please, please.
Mm, So my question is about that that respiration.
That?
So what is respiration?
Bath, respiration. Did you guys understand what he's asking?
No,
Yes,
no,
sir.
I'm not.
Respiration.
What is he
Earth,
saying?
Earth, first thing is that when we are discussing a topic, your question should be only related to that topic. When we finish this topic, then you can ask a different question on different topic. Oh, okay. So we'll hold on to that one. Let's finish first the topic we are right now at. Okay, Earth. Thank you. So, all right, that's very good. So, do you think, Aryan, you can present this shifting of the what is that? D color, red color, a separate
Redshift.
presentation? Because yeah, I'm not very familiar with the experiment you are talking, Mallikji, about that. They discovered that how they are shifting. So I would like to know. These kids should make a presentation then. If that, how did we come up with the idea that this universe is expanding by this red color spectrography, which you are talking about?
No, Amarnathji, you want Aryan to explain this again?
Yeah. I would like to see a whole detailed
Yeah, Aryan,
presentation on that
can
one.
you explain in simple?
Yeah.
No, of course, Amarnathji can understand very complex things also.
Well,
So you
make it simple. Now, I'm getting old. My brain is kind of shutting down gradually. So,
no, no.
uh,
Have you read the recent newspaper? They say the brain is most, productive from 70 to 80.
Wow.
So now you're in the productive period.
Okay. So I'm not too much in all these theories, but I always wanted to understand that what is the theory which explains how we say that this universe is expanding. So if you guys can make some presentation on those, like today I learned that this red color spectrography is one of the methods they have come up with. I would like to know more about that, but that is something for the future.
Yeah, Aryan, you want to try once again to explain to all of us?
Okay, sir.
Yeah, you
So,
have to use very, very commonsensical language, which we can understand.
okay, sir. So, let's assume that if I have an antenna which is standing like it's a fixed position away from me, and I'm receiving that on something like a computer, and the difference between each pulse is five seconds, let's say. But what will happen uh, if the signal is moving away from, if the antenna is moving away from us, like at a uniformly accelerating motion, like and after that we'll compare the rest position of that, like that was 10 seconds, and we will compare that to the signal that we have now received, and do the necessary calculations. I think so we subtracted the rest position, like the original position of that galaxy and the rest position, and we then did some maths on that. I can't remember it, but it's like that. If if we want to, if I think so it made it simpler. It's like it's like finding out the differences, the distance it's calculating, uh, the distance it's moving by calculating the amount of signal difference we are getting, uh, the delay in signal. So that, I think so that can be a good explanation of this. So, Malik sir, is that correct? Like, is there any flaw in this?
Yeah, no, yeah. So you use the word accelerated motion. No, no, even in unaccelerated motion, also this will happen. No, in fact, let me summarize what Aryan is telling actually. Just first point which Aryan has made is that from quantum mechanics and from different observations, we learned that all atoms have got a signature frequency. This is very important. Like, say, hydrogen will have a particular, because the energy difference between two levels, because of quantum mechanics, is fixed for different atoms. So every atom of an element and different elements have different signature frequency. So just by getting, suppose I take the frequency of, let us say, something, say flame or anything, the lines I will see, it will depend on what is burning there. It will have a signature frequency. Now, this is what was used, that all the stars, they were emitting light. So people analyzed, as Aryan was telling, that lot of work was done, very, very, very sincere and hardworking work was done actually to establish this. Even C.V. Raman has a contribution in that, our Indian scientist. So what was there is that first thing to note is every atom of an element has got a signature frequency. वो कहीं से भी आए, स्टार से आए कि सन से आए, कहीं से भी आए. ये सन से आए तो हीलियम का लाइन दिखाई पड़ता है. वही हीलियम जो पर अर्थ पर है, अर्थ पर भी हीलियम से वही लाइन दिखाई पड़ेगा. अब now what Aryan is saying, that suppose the star is moving away from us, then what happens is that this, ये जो number of waves, ये जो wavelength जो है ना, if it is moving away from us, the wavelength will increase, means frequency will decrease. And that is why it is called red shift. Red is a lower frequency of the light. So it is shifting towards the red. मान लीजिए एक लाइन ब्लू लाइन आ रहा है एक स्टार से, so showing that it has some sodium. ठीक है, और वो लाइन जो है ना शिफ्ट कर जाएगा जरा सा थोड़ा सा टुवर्ड्स रेड, एंड डिपेंडिंग ऑन द शिफ्ट आई कैन कैलकुलेट वो कितना स्पीड से हमसे दूर भाग रहा है स्टार.
Mm.
And that is how we calculated, and it was found very interestingly कि all these stars, galaxies, सब में red shift ही हो रहा है, blue shift नहीं हो रहा है towards higher frequency.
Mm.
All red shift. That means everything is moving away from each other. Just
Mm.
like a balloon, you know, in balloon if you put dots, lot of dots, and if the balloon is expanding, all the dots will be moving away from each other.
Mm. Okay,
See,
very good.
yeah,
Thank you.
so if you are one of the dots standing on one of the dots, you will find all the dots are moving away from you, and you will come to a conclusion that this balloon is expanding. So that is how Hubble came to conclusion that the universe is expanding.
Oh, okay,
And
very good.
and there is one very interesting thing now, that now the universe now they find is expanding in an accelerated way. So they are now blaming dark energy for this, because
Mm.
जितना मास कैलकुलेट किए हैं ये लोग यूनिवर्स का, उससे इतना एक्सेलरेटेड मोशन नहीं होना चाहिए, पर ये
Okay.
हो रहा है. So this has become the biggest mystery, which the astrophysicists are trying to solve. It's a very interesting problem. I think
Yeah.
when Aryan and Saksham and Earth they become a little bit bigger, they'll come across these problems. You have to solve these problems.
So Aryan, another question I have is that what is that energy? Where is that energy which is being utilized for this expansion of the universe? Where is that energy coming from?
uh, it's a property of the universe. It has been there for, like, uh, we the force that we blame is dark energy, which is accelerating the expansion of the universe. But as we know that if there's something, if the term dark is used in front of something, it means you do not know much about it. So we don't know much about it, but we blame dark energy for it. So yes, dark energy is responsible for this expansion.
Okay. Yeah, Maliki, my simple question was that there is a potential energy which gets converted into kinetic energy, and uh, so where is the potential energy of the whole universe pretty much concentrated? Do we understand that?
No, it's like this. If the universe is filled with mass,
Mm.
so there is only gravitational force which is impacting on the movement of the different galaxies. Now, additionally, even the dark energy also contributes to this expansion,
Mm.
which has not been found yet. In fact, recently, only just 1 week back, there was a theory. He says that he has come up that no, there is no dark energy, there is something else. So it is under process of investigation. But there is something which is making it move faster. Is it that we have not estimated the mass of the universe correctly? Because they say the mass which we have investigated, and if we correlate with the expansion, then only 5% of the mass is what is there. 95% is the dark mass and dark energy. But it has to be found, because the science doesn't believe in these kind of things. It has to be found
Yeah.
somewhere.
Okay, Saksham, you have a
So
question? Go ahead. Saksham has a question.
where is Saksham? Yeah. Yes, Saksham.
Unmute. Unmute yourself, Saksham.
Um, Sir, my question was, why does why does not the other states of matter are, you can say, heavy? I and the main question was, have you heard about heavy dark matter hypothesis?
I have not heard Saksham. I'm
What
poor in.
hypothesis? What is that hypothesis you are talking
Why
about?
didn't it? Yes.
Heavy dark matter hypothesis.
Heavy?
Heavy dark matter hypothesis.
What is the spelling? Heavy dot.
Sir, I'm
Heavy
typing.
Type
No,
it.
no,
Yeah,
no. Yeah.
heavy dark. I think he's saying heavy
Okay,
dark.
heavy dark. Are you
But
saying
Yes,
heavy dark?
yes, sir. Heavy dark matter hypothesis.
Now, let's not discuss about the hypothesis because they are in your. See, a hypothesis is something which people you can present something, I can present something, but that doesn't become science. A hypothesis still remains until there is some evidence. थोड़ा सा भी evidence होना चाहिए कि इसमें कुछ सही है. अभी भी डार्क एनर्जी के बारे में इतना सारा हाइपोथेसिस है दुनिया भर में कि इट्स वेरी डिफिकल्ट व्हेन एस्ट्रोफिजिक्स का कॉन्फ्रेंस होता है, मारपीट होने लगता है. There are
Okay, sir. So I
there
had
are
one more
so many
question.
there are so many theories,
yeah.
but ultimately only that theory will be accepted which has evidence. Otherwise, no. Just so लोग कूड़े कचरेदान में फेंक देते हैं.
Okay, sir. So I had one more question.
Yes. To whom? Aryan or to Amarnath ji or to me?
Amarnath sir.
Acha, okay, good. Go ahead.
So the most of the states of matter we have seen like solids, liquids, most of them are very lightweight. As you can see, the liquids and particles are far apart, so they are light, and in gases they are even lighter, and it's so on. So why does most of the states of matter are very light? Why can't they get heavy?
Mm. Oh, very good question. What do you think? You already. It looks like you already answered the question. Didn't you discuss about the density yourself? That there is a space between, like the solid molecules has least space between the atoms,
Yes, sir.
liquid has more, and
Intermolecular.
gas has most. So if the gases have most space in between, what will happen to this density? It is the least dense material, right?
Yes, sir.
Okay, so then if it is the least dense material, then what will happen to it?
The mass will, I think, decrease.
Okay.
And, and sir, but as you're saying, say until gases. So if we go even higher to plasma or other states, so why does the solids have the highest mass?
Hmm. That is a different question. Why solids have the, I mean,
It's because
uh,
their molecules are tightly packed, and like as we know that water at 4 degrees Celsius is the heaviest. So it's just about their arrangement and their configuration of their molecules. It makes them.
I think Aryan, his fundamental question is that why they are tighter molecule in the solid. That
Yes, sir.
is what
That
he
was
is
the main
asking.
question.
Yeah, yeah. Why we have, why they are tightly constructed? That is his question. And okay, I don't know why solid are so constructed. I think there has to be an answer. Malinji, I mean, it
Yeah.
is a proper. We learned it as a property, but the question is that why it is constructed like that.
No, so solids, as you see, what the difference between solid, liquids, and gases is what? In the solids, you have the closeness of the molecules are there. Question arises now that solid में भी जो molecule है और भी नजदीक क्यों नहीं जाते हैं? Now these molecules, when they come near to each other, then um, they start feeling the repulsive force also between the molecules which are there. Now, by reducing the temperature, you can bring them a little bit together. By increasing the temperature, you can again increase the distances between them. And at the phase transition, that means when solids go to liquid, well, that is a phase transition issue. Physics में इसको बोलते हैं phase transition. A sudden change takes place, and they all become free, but not enough free. They will stay in the liquid stage and only don't escape also. They will be there. एंड और भी आप टेम्परेचर इंक्रीज करेंगे इतना डिस्टेंस. अब देर इन द लिक्विड नाउ whatever force is felt is there, but as soon as you increase the temperature there is a phase transition, it goes to gas. And now उस molecule के बीच में अब कोई भी नहीं है, कोई भी attractive force नहीं है, आराम से सब घूमते हैं. So it is basically the forces between the molecules which decide these things.
And the forces between the molecules are, what are the different forces? One is the gravitational, you said. What is the other one?
No, no, it's not. Actually, it is termed under the one that it's called the Van der Waal forces.
Okay.
Van der Waal made extensive study of these things. So how they and now, of course, it is even getting quantum mechanically solved these problems. So yeah, it's a complicated issue. But
Okay.
experimentally, Van der Waal was the first one to do this.
Okay. So
वैंडर
here
वाला
is,
पढ़े होंगे, वैंडर वाला पढ़े होंगे, केमिस्ट्री में आपके होगा, आप भूल गए होंगे, पर
yeah,
वैंडर
yeah.
वाल या
What I'm saying, Saksham has to now make a presentation. That is his homework on the Van der Waal forces. Yeah. So basically,
not
why is that?
solid, liquid, and gases. What's the difference?
And
Yeah.
sir, I had one more question that there are four fundamental forces: strong force, weak force, magnetic force, and gravity. So we see strong force.
Not magnetic, electromagnetic.
Yes, sir, electromagnetic. That was my mistake. So we see strong force in the atoms and electromagnetic force. There are magnet and the gravitational force almost everywhere in the cosmos. But why do we see weak force in the lowest amount, like
In
inside atoms or near a nucleus, etc.?
Oh, I think Saksham is asking this question second time. That's my last time. He didn't understand. No, no.
Yes,
The
sir.
difference between the yeah. Oh, Aryan, you want to say something?
No, sir, I was just saying yes that he has asked this question again.
Yeah, he had asked this question. I had replied. Probably I couldn't make him understand. I'm sorry, Saksham. No, what I'm saying that these weak forces are very, very short range force, even shorter than the strong force. So that's why you feel in the nucleus, but in the nucleus, when the nucleons means protons and neutrons, they come extremely close. Now, to tell you what kind of closeness, I will tell you, it is 10 to the power minus 17 centimeter. Can you imagine this figure? 10 to the power minus 17 माने 1 by 1 पर 17 ठो जीरो होगा. जब उतना क्लोज आते हैं तब वो वीक फोर्स को फील करते हैं. जैसे ग्रेविटेशनल फोर्स पूरे इन्फिनाइट तक जाता है ना. इलेक्ट्रोमैग्नेटिक फोर्स भी बहुत दूर तक जाता है, पर ये वीक फोर्स जो है ना बहुत शॉर्ट रेंज में फील होता है. सेम स्ट्रॉन्ग इज 10 टू द पावर माइनस 14, वो थोड़ा दूर तक फील होता है. सो न्यूक्लियस में जो होता है ना स्ट्रॉन्ग फोर्स प्लेज ए रोल, एंड ऑल्सो ऑफ कोर्स वीक फोर्स ऑल्सो प्लेज ए रोल. आपके बॉडी में ही अभी जो है ना, आप जो पोटेशियम खाते हैं ना, केला में बहुत पोटेशियम होता है, उसमें K40 भी होता है. वो वीक फोर्स से जो है ना आपके बॉडी में कैल्शियम बन जाता है. So in your body you are having weak forces playing the role.
Yes, sir.
Yes,
Sir, I had a question.
yes. अच्छा,
So,
फर्स्ट लेट मी राकेश, आपको ये समझ में आया, ये रेंज का समझ में आया क्या?
Yes, sir.
10 to the power minus 17.
हाँ, ये इसका कारण क्या है कि थ्री फोर्सेज जो है ना, स्ट्रॉन्ग फोर्स जो है वो भी एक्सचेंज ऑफ ग्लूऑन से है. ग्रेविटेशनल भी जो है इज नॉट ए फोर्स एट ऑल. अब जब बड़े हो जाइएगा तो देखिएगा कि आइंस्टीन ने साबित कर दिया कि ग्रेविटेशनल फोर्स कोई फोर्स ही नहीं है. मैंने न्यूटन ने जितने जितना सिखाया वो सबको उन्होंने काट दिया. और इलेक्ट्रोमैग्नेटिक फोर्स जो है ना इज इनफाइनाइट एग्जिस्टेंस है, उसको बहुत दूर तक जाता है. because it exchanges using photons, virtual photons. Weak force में क्या होता है कि this is a weak force is a very interesting force in which there is no exchange, but W and G bosons they play a role in that. So suddenly proton जो है suddenly decides to become a neutron, and neutron decides to become a proton. ये आपके बॉडी में भी हो रहा है by the way. तो जैसे कि सन में जो होता है लोग कहते हैं ना कि प्रोटॉन का बना हुआ है, पर प्रोटॉन से फिर हीलियम कैसे बनता है? न्यूट्रॉन होगा तभी ना। वहां पर भी प्रोटॉन सब वही वीक फोर्स के कारण न्यूट्रॉन बन जाते हैं, तभी तो हीलियम बनेगा। हीलियम आप सुने हैं ना कि 2 प्रोटॉन 2 न्यूट्रॉन होता है, और लोग कहते हैं कि इसमें जो है सन में जो है प्रोटॉन से सब हीलियम बनता है। अरे भाई हीलियम बनता है तो न्यूट्रॉन है ही नहीं तो कहां से बनता है? इट्स बिकॉज ऑफ द वीक फोर्स। तो काफी इंटरेस्टिंग है ये। यस आर्यन,
Yes, sir.
या व्हाट
So,
इज योर क्वेश्चन?
so my question like was about the daily life objects. So, as we know that like the AC school, these things by the Gene Thompson law that you had told me earlier. So, I had another question. Whenever we change the temperature in the AC, what parameters, what variable changes to give us that specific temperature, and how do we know that?
What is your question?
हिज क्वेश्चन इज कि हम लोग जब एसी है ना तो रिमोट से चेंज करते हैं ना, 24 डिग्री, 23 डिग्री, 22 डिग्री, तो हम जब चेंज करते हैं टेम्परेचर तो एसी में क्या चेंज होता है? अच्छा,
Okay, so
नहीं पर अच्छा पंकज जी अच्छा आर्यन का ये क्वेश्चन है, he has really stunned me actually. I never thought about this. In the present day ACs what are they doing? In the old ACs they used to do this cycling को चेंज करते थे, बट
no, sir.
आजकल के एसी में सुनते हैं कि ये नहीं होता है। आई डू नॉट नो प्रेजेंट डे एसीज में। दिस वीक आई एम गोइंग टू स्टडी अबाउट इट, टिल यू नेक्स्ट टाइम
Okay.
प्रेजेंट डे एसीज में क्या हो रहा है।
Sir, but the cycle one was also a very good example for asking that question. Because if
या
I'm driving at cycle at 20 speed and I'm driving another uh, cycle at 10 speed, so what is the difference? Like it's like asking how fast would be my feet moving to create that specific speed. So I think so it can be restructured like that. So what I think is that as you mentioned, uh, if something like thin thin tube, if I pass air through it very in a small space at through the inverse square law, it will get colder air on the other side. If we, I think so, manipulate the speed of that the air inside that tube, we can maybe manipulate the temperature. So I just this was just like a question that I had from the previous week, but I couldn't answer it, so I just uh, told it here.
So you have this is a very good idea you have, but question is how do you change the speed of the molecules?
Yes,
एक तो है जो जूल्स थॉमसन इफेक्ट में जो होता है ना कि नोजल के थ्रू से एयर को निकालते हैं।
yes, sir.
So that will depend on the inlet pressure and the whatever is the outlet pressure. The difference of the pressure will decide कि कितना स्पीड से जा रहा है। But how do you change this? I do not know actually. Give me 1 week's time. I will try to see nowadays what they do. There are so many technologies in the AC which has come.
Sir,
Yeah, huh? Yeah. हाँ, नहीं नहीं, वो पंकज जी वो एनर्जी को कैसे मैनिपुलेट करते हैं? हाँ, नहीं एक तो हम जानते हैं कि वन प्रेशर वाज यूज्ड, प्रेशर। पर आजकल के एसी में क्या होता है पता नहीं, दे से इट्स वेरी एफिशिएंट मेथड। व्हाट इज दैट एफिशिएंट मेथड, हमने कभी दिमाग नहीं लगाया है। लेट मी ये, आप लोग भी, मे बी पंकज जी इज राइट, ही इज टेलिंग दैट एनर्जी मैनिपुलेशन हो रहा है।
सर।
एक तो प्रेशर मैनिपुलेशन इज वन ओल्ड टेक्निक which is there already. I
सर
don't know whether that has changed over time or what it is.
सर हैव सर लाइक
एक और चीज हम बताते हैं कि कूलिंग का जो है ना, इन some places like in the satellites, they will use a different. Some of the materials have got a negative, means as the current increases, the temperature decreases.
ओके
So, yeah, there are some materials, as the current increases, temperature decreases. These are very interesting materials and they are used for cooling this stuff.
ओके सर
So, sir, as are you saying that current increases and temperature increases? So, how does it will happen? Because current is carrying electricity, and that
Yeah.
electricity is having very high temperature.
सर आई
No, electricity is not at a high temperature. No, no, there are some materials, they have a opposite property. Usually, most of the 95% of the materials, if you pass current, the temperature increases. But those are the materials, and they are the joints. Those joints, they behave in a very different way. Some other day we'll talk about it, why those joints they behave in a different way,
ओके
and the temperature decreases. Very interesting it is. In fact, Amarnath ji, recently, I was going to my village, so and I don't have a freeze there, so I purchased a something, uses this principle. छोटा सा means 6 इंच by 6 इंच का रेफ्रिजरेटर, जिसमें करंट पास करके टेम्परेचर डिक्रीज होता है, so that I can take my insulin in that. And so I used it in the village. It is available in the market now.
सर
Very nice.
add add another
Yes.
question.
Yes.
So sir like in college, which degree did you take?
No, I went through BSc Physics honors.
Okay,
But yeah,
BSc.
from school time, I was thinking I want to become a geologist because I wanted to travel around, look at the mountains and this and that. But unfortunately, it so happened. Of course, I had interest in physics. My father wanted me to become a doctor. So, somehow I managed to convince him कि डॉक्टरी तो मेरे से होगा नहीं, आप हमको जबरदस्ती मत कीजिए। अच्छा, उस समय जो था ना, बहुत खराब हालत था, जयप्रकाश नारायण जी का रिवॉल्यूशन चल रहा था और
Sir, as you say,
किसी को नौकरी नहीं मिल रहा था। तो लोग पूछते थे कि आप फिजिक्स पढ़ेंगे तो आपको क्या नौकरी मिलेगा, सो मेनी फिजिक्स पीपल आर कमिंग आउट। तो हम सोचे कि जियोलॉजी पढ़ते हैं, पर जियोलॉजी के क्लास में अब एक्चुअली आई टुक एडमिशन इन जियोलॉजी इन दी कॉलेज, जियोलॉजी ऑनर्स। वो 2 क्लास के बाद ही जो है ना, हमने डिसाइड किया कि हम जियोलॉजी नहीं पढ़ सकते हैं। आई हैव टू रीड फिजिक्स ओनली।
So sir,
sir,
have you heard
ये
about the black magic chart or the Smith's chart?
ब्लैक मैजिक,
Black magic chart, like people say, because it's way hard to understand. Smith's chart.
I do not know what is this. Sorry, sorry. Can you explain to me a little bit?
So, sir, like it's pretty interesting. So it talks about like if I give if I give a signal, then the signal comes back also. And if that happens, what happens is that the wires, like the big uh, the big wire lines, they burn. And to overcome that, they came with the black magic chart or the Smith's chart. So uh, I still do not understand it. I just heard it somewhere. So I thought of like studying about that too. Its name is pretty unique.
Yeah, absolutely. I want to encourage you to study black magic chart.
Oh,
But no, no, I don't know what it is. But really, I don't know about it. I'll read it. Is it available in the books? Black
sir,
magic
I think so.
chart. It is
It,
called
it
Smith chart.
yes, sir. So I
I,
think so.
I, I will try
It's
to
taught
read about it.
it's taught
What
in
it is.
electrical energy engineering courses.
Okay. Maybe Amarnathji, can you throw some light on this black magic chart?
I don't know much about it.
Oh yeah, ब्लैक मैजिक तो हम लोग वो जानते हैं वो सुपरस्टिशन वाला मैजिक.
No, sir, I think so. It's has its name is being black magic chart because it's very hard to understand. So it has something to do with resistance, voltage, current, and these things. So it's all because of this chart that the power lines are still like in a very good state and have not been burned.
अच्छा.
Yes, sir.
नहीं, नहीं, इलेक्ट्रिसिटी के बारे में ऐसा कुछ नहीं है जो अभी तक समझा नहीं गया है. Let me try to read it what it is. The name is very interesting.
Yes, so I think so. It's an old topic and it's in every engineering electrical engineering course.
अच्छा, अच्छा, let me just go through it. Let me just see.
Okay.
पर इलेक्ट्रिसिटी के बारे में ऐसा कुछ अभी नहीं है जो कि नहीं समझा जा चुका है. I think people have done enough,
Yes.
so बहुत इससे समझ में आ गया है. हम कैसे जानते हैं कि समझ में आ गया? इस तरह जानते हैं कि कोई भी चीज फेनोमेना को हम यदि प्रिडिक्ट कर पाते हैं कि ऐसे ही होने वाला है, इफ आई अप्लाई दीज रूल्स, दैट मीन्स एवरीथिंग इज अंडरस्टूड.
Yes,
और
it's
यदि नहीं समझ पाते हैं, देन देयर इज समथिंग व्हिच आई डोंट अंडरस्टैंड.
so it was developed in the World War II
हम्म.
for the power lines communications. So like Germany, Japan, and I think so there was another country like the UK. These
हम्म.
three people were doing that, and they all came up with like very similar results. So this is like I've astonished that like in wars, scientists are the ones who do the most, even and they inform their leaders about uh, these new technological developments that could help them in progressing more and more. So I think so. It was it was Britain that came up with this, or I don't remember it, but they used it to fix their power lines that were burning.
I
Yes,
see. Okay. They have given some nice, interesting name to some phenomena, right?
yes,
Uh, आप भी देखिए गूगल में, गूगल ने, हम भी देखेंगे कोई किताब में जो दी है.
oh,
और कोई क्वेश्चन है आप लोगों के पास?
yes, sir. Uh, section is
Sir, I had a question.
हम्म.
Sir, my question was, why does proton chain nuclear fusion only occurs in small stars. Why does it not occur in the big stars?
नहीं हमने समझे क्या है फोटोन फोटोन
Proton chain nuclear fusion. Why does it occur in small stars like our sun, and don't occur in big stars? Like big stars have thermonuclear fusion and small stars have proton chain. Why does it so?
Sir, I
yes
think so.
no you mean to say that in small stars the fusion is created by photons.
No, sir. Small stars have proton chain nuclear fusion, and big stars have other type thermonuclear fusion. So why does it so? Why does small stars rarely have thermonuclear fusion?
No, one thing is there are two phases of this nuclear phenomena. See, for nuclear fusion to occur, the temperature has to be very large.
Yes.
The temperature has to be very large. Then only these protons, they collide and things like that. But for thermonuclear, means where the fusion process takes place, temperature is not the consideration actually. Is that what you are saying? Something? Uh, when the temperature is
Sir, I
small,
can answer.
when the temperature is small, you see, fusion cannot take place. Like in the sun, it is only in the center that fusion takes place. And that needs very high temperature.
Uh, Sir, I think
But
so. I got his question. It's like uh, small stars have the capability to only fuse uh, these specific types because for other reactions, for maybe carbon or something else, they would require a larger mass like pressure and these temperatures. So that is why small stars, I think so, do proton star chain reaction. So maybe that's the case.
So why does big stars can't have proton chain nuclear fusion? Why does only small stars have?
So they do have like this, like if the whole thing, if there's no hydrogen left, how like I think so that it happens in the core, and it then transforms into other heavier elements, and then they fuse to other form heavier elements. So if it's happening for the small mass stars, it would be also happening for the big mass stars, right?
So why does it is rare? Means that thermonuclear fusion is happening in large amounts, but proton chain in small amounts in big stars. But in small stars like our sun, it is reversed. Like thermonuclear fusion happens in small amount, and proton chain nuclear fusion you see happens in the big amount. So why does
So
the
it's
situation is
only way
reversed?
like it's only way if you have like in biology this, and there would be a chapter of dispersion. So it's like the difference between breathing, like the thing that we do by lungs, and dispersion is through that. It just happens. So like it's
sorry.
fusion is a more advanced, like a more advanced stage of that thing. So, and in small stars like R, that happens because it's only way to be like to be stable. So, if that thing is not happening there, the small things that are going to happen will take place and would be the reason for its stabilized for its stable state.
No, no, Aryan. As you said that proton chain nuclear fusion is the only way. So why does it is only way? Means why does thermonuclear fusion
So,
happens in very small amount?
okay,
It can
so
happen in huge amounts, and proton can happen in small amounts. But the situation is reversed in the stars like sun. So
So
why it is reversed?
I've already answered that. It's because it's like its capacity is only if if let's say if you can run 10 kilometers, you won't be able
So
to
why
run
does the
15.
capacity matters?
Like if I don't have the enough temperature, enough, like if I'm cooking something and I just run out of gas, I won't be able to cook it more, right? I have to settle for less. So that's what's happening with the with that star. It can't do because it does not have the particular circumstances to do that.
I
So
don't get you. It means
No, Saksham, the difference in small star and big star is that in small stars, the pressure developed is not high, and pressure is proportional to temperature. So I'm trying to understand your question now. So this is one main difference which takes place in big stars, which can produce by gravitational pull. The whole thing becomes smaller, then pressure develops, temperature increases, and the fusion starts. So, so I don't know whether your question is related to this or has Aryan's answer satisfied you?
um no sir, I don't get satisfied by Aryan means he was
Yeah, Aryan. So he is not satisfied by your answers.
can you like describe the place that I didn't do well?
okay. So do you understand what is proton proton chain nuclear fusion?
Yes.
So what is it? You should answer it first.
Okay. So when uh, when an atoms with protons meet to form heavier elements.
So the amount of atoms should be less or more.
Like if it forms two like a heavy like two lighter molecules, uh, two lighter become a heavier one. So that's the case. Heavy lighter is
So
getting
you
heavier.
see, like the case should be four hydrogen atoms convert into one helium atom, or four helium atoms convert into one hydrogen atom. What should be the case?
The four hydrogen into one helium.
Yes, yes, you're right. Why why does this happen in small stars? Big stars also have hydrogen and even in the higher amount, and helium also in the higher amount, and the pressure exerted is a more. So what so proton proton chain nuclear fusion should happen in higher quantity. So why does not happen even?
It does happen. That's I think so that it will happen because like if I have 10, if I have some amount of hydrogen and some amount of helium, and let's say if I need to make combine some amount of helium to get a heavier element, what would I do? Combine those hydrogen atoms into a helium one, and then combine the helium with the helium to make the heavier ones. So it does happen, and like after that, uh, the proton chain reaction, like it happened only once in this case, but it happens a lot like in the case of bigger stars. It happens, but if we compare it to the small stars, so they are not able to fuse helium or helium together to make more heavier elements. So it's their only way to do that. So so that was my explanation. So do
So
you have?
it's possible that proton proton chain nuclear fusion and thermonuclear fusion should happen in the same star.
Yep, they can.
Sorry, one thing. No, Aryan, see, a proton combining with a proton is not a feasible thing. It is not stable at all. It cannot.
Okay,
But two protons will be electrostatically repulsed. So unless the proton doesn't, by the weak force, doesn't convert into neutron, they won't bind together. So proton-proton thing will become neutron. That is what happens in the sun.
yes,
And
two,
then that chain reaction comes and then the helium is formed. So it is by
yes,
the weak force, that this happens. But proton don't react at all. I mean, they don't find a They don't find anything. There is, क्योंकि उसमें न्यूट्रॉन ही नहीं है ना स्टेबलाइज करने के लिए. So two
So, sir,
protons, they will need two neutrons to stabilize.
Yes, sir.
so sir, why neutrons is important to stabilize? Why can't it be?
Because of the strong force. You see, there is in the nucleus. In the nucleus, there is the strong force is there. The electrostatic force is there. उसका balancing होता है, and weak force is there. So depending on the distances, they operate in different ways. दो प्रोटॉन आएंगे एक साथ में तो पहले दे विल फील इलेक्ट्रोस्टैटिक रिपल्सन, पास में आएंगे ही नहीं. मान लीजिए उनका वेलोसिटी बहुत है तो पास भी आएंगे तो क्या होगा कि वीक फोर्स के कारण some of the protons will get converted to deuterons and they will combine to form a deuteron.
So, what will happen if a deuteron forms?
So what will happen if the
Deuteron forms.
always deuteron forms in the sun? From proton to helium is through the route is via deuteron. चलिए और कुछ क्वेश्चन है अभी क्या? पर आप लोग स्कूल का क्वेश्चन नहीं पूछते हैं तो ये because Aryan, what happens is that other children, they might feel कि आप
Yes.
लोग खाली एस्ट्रोफिजिक्स डिस्कस करते हैं. कुछ स्कूल का चीज भी डिस्कस कीजिए कि आपके स्कूल में जो पढ़ाई हो रहा है वो आप समझ पा रहे हैं कि नहीं. फिजिक्स हो, केमिस्ट्री हो,
So,
बायोलॉजी के. हाँ.
so
चलिए अब आज काफी हो गया. I
yes,
think we have
yes.
crossed the limit by 30 minutes.
ओ अच्छा.
हाँ, तो और अपने दोस्तों को भी लाइए आप लोग. It's not
And
enough. आप लोग 2 ही आदमी अगर रहेंगे तो बड़ा मुश्किल हो जाएगा.
हाँ, हम लोग
We need more students.
Aryan, you must come up with school questions or things which you don't understand or make us understand others.
Yeah.
Oh, sorry.
All right then. I
And
guess
sometimes
that
we will
should be enough for
discuss
today.
astrophysics also. Yeah, everything we will discuss.
Oh, sir.
Yeah.
and
But let's discuss more about your school things so that other people can also join. नहीं तो दूसरे लोगों को तो आप लोगों को जितना पता है एस्ट्रोफिजिक्स, कई बीएससी ऑनर्स वाले को नहीं पता होता है.
sir, sir, I have one more question. And sir, I have one more question.
Go ahead.
Is it about what?
No, sir, it is affiliated to you only, and it is not related to science, as you
Oh, oh
said,
my God.
regarding astronomy and astrophysics. So,
No,
my
no, I'm not. Saksham, I am not astrophysics.
no,
I am an accelerator physicist, which
no,
is closer to, yeah, I am an accelerator physicist.
okay, sir.
So,
So you
so
said,
my job was a little bit of, electromagnetics and little bit of nuclear physics.
okay, okay, sir. So my parents are insisting me to become a doctor, but I want to become an astronomer. So what to do? Like you can,
Astronomer or astrophysicist?
yes,
Like there are differences between them.
yes, that too I know. But my parents are insisting me to become a doctor, but I don't want and become an astronomer. So what to do? Like
Very simple answer. You have long way to go to matriculation, right? Up to high school, right? Which is high school, everything is common. Physics, chemistry, math, biology, science, everything is common. Only after that you can branch whether you want to be a physicist or engineer or doctor or whatever you want to. So right now you focus on all the subjects of science for next how many years? Maybe 8 or 9 years.
Yes.
And so you have plenty of time to decide. When you are at that time, you can decide in the next 10 years whether you want to do, because right now everything which you are studying is the basic foundational courses for both medicine, doctors, and engineering and physics, everything. So it is too early to decide. This is not the time to talk about whether you want to become a doctor or engineer. Right now, we want to discuss. You want to become a good high school graduate first.
Yes, yes, very correct. What Amarnath ji has told you. See, in your life, you need knowledge, basic knowledge of biology also. Even if you become an engineer, someone who understands biology, keeps good health. It is now very well understood. Someone who is very poor in biology will not understand his body himself. आपको तो पहले सरवाइव करना है ना, तो थोड़ा बहुत बायोलॉजी आपको आना चाहिए, थोड़ा बहुत फिजिक्स आना चाहिए, थोड़ा बहुत केमिस्ट्री आना चाहिए. अभी तो all the basics you should learn now. And then
I
say
have an
after
interesting. I have an
class
interesting
12.
story. I have an
Yes,
interesting story to share. You
yes,
already
sir.
heard. You already heard from Malik ji that his father wanted to be his father wanted him to become a doctor. My father also wanted me to become a doctor. And then when I was in the ninth class in Watson School, I went 2 3 times to biology class, and I still remember my teacher's name, Ramesh Jha, and I did not understand phylum, protozoa, coelentra, and all those things he was talking about in my first 2 lectures. I said, this is not the thing for me. But that is not the only story. There is another story I tell you. I also told my son when he was going in the college, I mean, starting in the college, here nobody talks in high school, but hey, you should you should become a doctor. So he said, okay, I'll think about it. And he took a biomedical engineering course. So I mean, basically, I told him to do the biomedical. The reason I asked him to do biomedical engineering is that, you know, in this country, United States, you go to the medical school after finishing your BSc. Yeah, you take an entrance exam after BSc, not like after matric or intermediate, like that happens in India. So here you can be a graduate in science, in any subject. You compete after your BA, BSc to into the medical school for another 4 years. That's the rule is. So, so I suggested him that, hey, you want to become a doctor? He said that, well, I don't think I have that temperament, but I think I can do one thing. I will do the biomedical engineering, which studies everything, even the medical science. And so his degree, undergraduate and master's, was in biomedical engineering. And guess what he's doing? He's doing he's making the medicine in Merck and Pfizer and Johnson and Johnson. So he picked a middle path. So you can do that one too. You can, instead of becoming a treatment, you, since you know so much of material science, maybe you will become a material scientist in the chemical area, and you can help with the new medicine to people to get better, right? So high school first.
Yeah, high school. And Saksham, that there is so much of physics in our body that you will be surprised that even one lifetime is not enough, to learn all the physics of our body.
Sir,
It
And then
is.
physics and physics and medicine, and there are there is a department called, we are talking about a spectrum and the lights.
yes,
There is a department called radiology. Do you know that?
yes,
There are there are a lot of physicists who are working in radiology department. I know one physicist who was giving the radiation therapy, which happens, which doctors do. So I know one physicist who was calculating the nuclear dose in those therapy. He was a by training physicist. He has never done medicine or never went to medical school. And and here he goes. He is considered doctor of the doctor because he can decide how much dose should go into the in the radiation therapy. So radiology is a combination of physics, medicine, and all that. There are many, many things you can do. Where so if you want India, they don't know. It is just like, do you remember that 200 years back we didn't know that we breathe oxygen. We all used to say that we breathe air. Later on, we have discovered now that we breathe oxygen, right? Same thing. People don't know in India, they said they become a doctor. But hey, you can be a scientist, you can be a physicist in the medicine area also.
चलिए. Okay, I think nice talking to you, all of you.
Yes.
Yeah,
So let us say goodbye.
yeah. Let's say goodbye today, and then
Yes, sir. Yeah.
okay. So students, now